Good morning everyone. In the last lecture, we have seen how to create a new source file and how to check the syntax error in the given source file. Right? Now in this lecture, we will see how to simulate the given circuit that we have designed using VHDL. Okay? So we will start to learn about functionality check about the design. Right? So we have already created the code for the AND gate. Now if you want to simulate the design, then you have to select the simulation. Right, in front of the simulation there is a bubble, you have to select it. Right, after selecting the bubble, the simulation will be selected. Right, now you have to again go to the device name, click right click, then select the new source. Why we are selecting the new source? Because now we are going to create a VHDL test bench. So basically what is VHDL test bench? VHDL test bench is a code that provide the input to the design that we have created. So in this we will pass the input to the design with the help of test bench. So that is a VHDL code, and that is known as the test bench. For that we are providing the file name, as we have already provided the name to the source file AND gate. We will write here AND gate underscore test, because we want to test the AND gate functionality, so we have provided AND gate test. Now in the source file we have selected the VHDL module, but now right now we are not going to create the VHDL module, we are going to create a VHDL test bench. So we will select VHDL test bench. Okay, then click next. After clicking next, you will find the associate source, which source is associated with this test file. So we have associated the source, that is AND gate. So you will find there AND gate, then go to next, you will find the summary. Okay, so add to this project, yes, that is added, where it is saved, the source directory, source type is VHDL test bench, source name AND gate test.vhd. VHDL extension means it is a VHDL file, right? Association, yes, that is already done with the AND gate. Then finish it. After that you will find in the design window of AND gate test VHDL file will be created, and in this editor window you will find the AND gate test underscore VHD dot VHD file, right? This same file you will find here, right? Everything will be same, like library included, use IEEE dot underscore std underscore logic underscore 1164 dot all, then entity AND gate test is. So in test bench, do not declare about the ports, because that is already declared in the source file. Now just we want to connect with those ports with the help of component. So we have already created the component, that is AND gate. Now we are doing one-to-one mapping of input port with the. So you will find the component. What is the component? AND gate is the component, and the port declaration, that is already we have done in the source file. A is the input port, B is the input port, and Y is the output port. Then AND component, right? After AND component, you will find the signal. So A and B are the signal that are initialized with the value of 0 0. Okay, std underscore logic in and out means its mode, input mode and output mode, in incoming mode and outgoing mode, right? std underscore logic is the data types that we are using. Okay, for booleans we are using std underscore logic. So we have initialized it. For output we will not initialize it, right? Because when the value of A and B will change, accordingly the value of output will change. This is our combinational block, so we don't require clock, so we have to make it comment. So dash dash, it will make the comment of the clock, right? Then comes the instantiation block. Instantiation block, we are instantiating gate and gate, right? Unit under test. What is unit under test? We are testing and gate, right? So we are doing the port mapping. A is map with A, B is map with B, and Y is map with Y. Okay. After instantiation, we will go to the clock process definition, because we don't require clock in combinational logic, so we will make it comment. We are doing comment it. Okay, all things will be commented here, right? After comment, you have to do the whole process to be comment, the end process, right? We don't require the clock process here, so we are commenting this block. The stimulus process. Stimulus process means we are stimulating our process. To stimulate the process, we have to provide the input. Without input, it will not stimulate the process, right? So what are the inputs in our case? We have A and B. As we know that in case of AND gate, if the value of A and value of B both have 0 0, what will be the output? Output will be 0. If value of A and value of A is 0 and value of B is 1, or you can say value of A is 1, value of B is 0, in both cases, what will be the output of Y? Output Y will be 0. If both the input A and B are high, then only you will get 1, otherwise you will get output 0, right? So we have to declare it inside the begin. Okay, so we are providing A value, first of all assigning 0, then B value we are assigning 0. Okay, after assigning the value of A and B initially, we will wait for 100 nanoseconds. In this duration, we will get the output Y. After that, we have to go to change the value of A and B for the next process. So we are providing A equal to 0 and B equal to 1. Right? So we are providing A equal to 0 and B equal to 1. And again we are waiting for 100 nanoseconds. Then in the next process we are providing A equal to 1 and B equal to 0. At last we will get both are 1 1, means A equal to 1 and B equal to 1, right? So we have assigned the value of inputs. We are changing the value of stimulus. Inputs are known as the stimulus. They are stimulating the process. Okay. Then wait for clock period. We are commenting this section, and then we will run the process, right? This will end the process, right? Because we have completed all the stimulus initialization, right? After doing this, we will go to the process window. So we have to select the AND gate test that we want to test. If we will select the AND gate test in design window, you will find in the process window ISIM simulator will come into picture, right? Then in front of the ISIM simulator there is a plus sign. Explore it. After exploring it, it will ask the behavioral check syntax. Just double click on behavioral check syntax. A process will run. Do you want to save the design? Yes, we want to save it. So yes, a process is running. In the console window you will find the message: the process behavioral check syntax failed. Why it is failed? Maybe there is some problem, right? So we have to check the errors. What are the errors? In the okay. When we are writing one binary number, so we have to write it inside the single quote, otherwise it will show error. Okay, uh, so we have to write inside the single quote. Get it, everybody? So in this way we have to write inside the single quote, otherwise it will show error. That's why we are getting this error. So we are rectifying all the errors. Just wait a second. Okay, so we have provided the single quote for all the bits. After that, again we want to check the variable check syntax, rerun the check syntax, save it. The process will run. Now, the right sign you will find here. In the console window, you will find the message process behavioral check syntax completed successfully. Means there is no behavioral syntax error in the given test bench. After doing this, we have to simulate the behavioral model. So just double click on simulate behavioral model. If you click on the simulate behavioral model, test bench window will open, right? So wait for few seconds, you will find test bench window. Okay, so we are getting this test bench window. Okay, fit to zoom to full view, right? If you will do zoom to full view, you will find the output test bench, where you will find the value by just moving this cursor. If A and B both are 0 0, output y is 0, right? If A is 0, B is 1, you will get output y is 0. Again, if A is 1, B is 0, you will get output y is 0. If both A and B are 1 1, then only you are getting output y is 1. Means the logic that we have designed satisfy the functionality of AND gate. So this is all about the functionality verification of AND gate using ISIM simulator. So this is the way to simulate the any design that we have done with the help of Xilinx ISIM simulator. Thank you for today's lecture.